let's look at some quadratic equations. So we have this thing called the standard form, and it can be defined as ax squared plus bx plus c equal to 0, where a, b, and c are real numbers and a is not equal to 0. We also have this thing called the zero factor property, and it's defined as if a and b are complex numbers with a times b equal to 0, then a is equal to 0, or b is equal to 0, or both are equal to 0. Taking a look at an example here, we want to go ahead and solve 10x squared plus x minus 2 equal to 0. So let's factor this out. We'll have 10x plus some sort of number, and then 10x minus a number. I'm going to go ahead and multiply this 10 times the 2, which gets us negative 20. So we want two numbers that will multiply to negative 20, and then when summed together will give us a 1 here in front of the x. So those two numbers would be a 5 and a 4. Alright, and then if we further reduce this, we can take out a 5 from here, so that will give us 2x plus 1. And then if we look at this other side, these will also divide by, looks like a 2, so that'll be a 5x minus a 2. So now what do? We know that these are equal to 0. If we use our zero factor property, we know that 2x plus 1 is going to be equal to 0. And we also know that 5x minus 2 is equal to 0. So if we solve for x in both of these two equations here, go ahead and subtract a 1. We have 2x equal to negative 1. So we'll get x is equal to negative 1/2. And then let's go ahead and add a 2 to the other side. 5x is equal to 2. And then this will give us an x is equal to 2/5. So now we have two solutions, and we can write them like this. We can say negative 1/2, comma 2/5. And usually what you do is go from smallest here to biggest. Okay. So square root property, let's take a look at this. If we have x squared equal to k, then x is equal to the square root of k, or x is equal to negative square root of k. And we can also write that as x plus or minus k. X squared is equal to 29. Let's go ahead and solve this. Go ahead and take the square root of both sides. So now we're left with x is equal to, and we can't really reduce the square root of 29 anymore. So this will be plus or minus the square root of 29. And we can write our solution like this. Example 2, again, let's go ahead and take the square root of both sides. So x is equal to the square root of negative 144. And if you recall, this will be negative 1 times 144. And the square root of negative 1 is actually going to be equal to I. So we'll be left with x is equal to plus or minus I, and then the square root of 144 is going to give us 12. So this will be x equals plus or minus 12i, and we can write our solution plus or minus 12i. Example number 3, we have x minus 8 squared equal to 24. Let's go ahead and take the square root of both sides. This will give us x minus 8 is equal to plus or minus the square root of 24. And now what we want to do is go ahead and get all our numbers to one side. So let's go ahead and add that 8 over to the right hand side. So this will give us x is equal to 8 plus or minus the square root of 24. But we're not done. We do want to go ahead and reduce that 24. So let's say 6 and a 4 will give us 24. 6 would be 3 and 2. And then 4 will be 2 and 2. And we can bring our pairs outside of our square root and then leave the other two numbers multiplied in the inside of the square root. So this will give us 8 plus or minus, and then the 2 can come out, and 3 times 2 will give us 6. So our final solution, we can say 8 plus or minus 2 square root of 6. So now we want to go ahead and look at solving quadratic equations using complete the square, and there are a few steps that we can use that will be pretty helpful. So step 1, if a is not equal to 1, we can go ahead and divide each side of the equation by a. Step 2, rewrite our equation so that the constant term is alone on one side. Step 3, square half the coefficient of x and then add this square to each side of the equation. Step 4, factor the resulting trinomial as a perfect square and combine the like terms. And then finally, we'll use that square root property for our final solution. So using complete the square, in our case a is equal to 1. We'll look at this first example. So when a is equal to 1, we'll go ahead and let's see. Step number 1, we have a is equal to 1, so we don't necessarily have to do step 1, but we do want to rewrite the equation so that our constant term is alone on one side. So constant term alone on one side, go ahead and add your 20 to the right hand side. So we'll be left with x squared plus 10x is equal to 20. And now that we have our constant term, we can go ahead and move on to our next step. So our next step says to square half of the coefficient of x. And then we're going to go ahead and add this square to each side of the equation. So let's go ahead and look at this. Our coefficient of x is 10. So let's go ahead and see what this will be. We want to square half of it. So 10 divided by 2 squared. That will give us 10 divided by 2 is 5, and then squared will be 25. So essentially what we'll have is 10x squared plus 10x plus 25 is equal to 20 plus 25, and this will give us 45, and then we'll be left with x plus 5 and then x plus 5. Essentially this is just factoring out x squared plus 10x plus 25. You want two numbers that multiply to 25, and then when added together will give us the 10. So now we can go ahead and further reduce this. X plus 5 times x plus 5, that's really just x plus 5 squared equal to 45. And to get rid of the square here, we can take the square root, which will give us x plus 5 is equal to, and remember, whenever you take the square root, add that plus or minus 45. So now we have x plus 5 is equal to plus or minus 45. Let's get this 5 on the other side. X is equal to negative 5 plus or minus the square root of 45. But we're not quite done. We can still reduce this 45. So two numbers that multiply to 45, that will be 9 and 5. And then 3 and 3. We can take our pairs and bring them out. So that will leave us with x is equal to negative 5 plus or minus 3. And then we'll leave this 5 underneath the square root, which gives us the square root of 5. So writing our final solution here, we will have negative 5 plus or minus 3 square root of 5. Okay, so we looked at when a was equal to 1. Now let's look when a is not equal to 1. So in this case, our a is going to be this 4 right here. So we need to go ahead and follow our steps. So let's see what our steps said here. It said if a is not equal to 1, divide each side of the equation by a. So we need to divide each side of our equation by this 4. So 4x squared, divide that by 4. 6x, divide that by 4 also, and then the 5 divided by 4, and then 0 divided by 4. Let's go ahead and simplify this real quick. So 4x squared divided by 4 is just going to give us x squared, and then plus 6 fourths x, and then we'll have 5 fourths equal to 0 divided by 4 is just going to be equal to 0. Now we need to go ahead and move on to our step 2. What did step 2 say? Rewrite the equation so that the constant term is alone on one side. So we do need to get our constant term on one side. Let's get it over to the right hand side by subtracting it. So this will give us x squared plus 6x divided by 4 is equal to negative 5 fourths. Alright, so now what we can go ahead and do is move on to our next step. So we just moved our constant onto one side. Now we need to square half the coefficient of x and then add this to both sides of our equation. So our coefficient of x is this 6 fourths. So it says we want to go ahead and take 6 fourths and then take half of that and then square it. Well, let's see what we can turn this into. We'll have 6, and then what this 4 will do is go to the bottom. So we'll have 4 times 2, and then we'll square that. This will give us 6 divided by 8 squared, which will be 3 fourths squared, or 9/16. Okay, so 9/16, we want to add that to both sides of our equation up here. And let's see what the final product gives us. This will give us x squared plus 6 fourths x plus 9/16 is equal to negative 5 fourths and then plus 9/16. And then further reducing this, let's see, we'll give ourselves some space over here. Let's take x squared plus 6 fourths x plus 9/16, and that's going to be equal to negative 11/16. And then further reducing this, we can actually factor out this portion right here to x plus 3 fourths times x plus 3 fourths. And the reason being, 3 fourths plus 3 fourths will give us the 6 fourths, and then 3 fourths multiplied by 3 fourths gives us the 9/16, and that's going to be equal to negative 11/16. And then these are essentially the same thing, so x plus 3 fourths squared is equal to negative 11/16. Take the square root of both sides. When taking the square root, don't forget to add your plus or minus, negative 11/16. Alright, we just have a few more steps to do. Let's get the 3 fourths over to the right hand side. So x is equal to negative 3 fourths plus or minus the square root of negative 11/16. And we can further reduce this because we do have a square root of a negative. this will be x is equal to negative 3/4 plus or minus the square root of 11i all divided by 4. And our final solution here, we can say negative 3/4 plus or minus the square root of 11i and divide by 4. That was a lot of steps, but we do finally have our solution here. Okay, looking at our quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This comes in really handy when we want to solve some equations. So let's use our quadratic formula when we have real solutions. So we have x squared plus 6x is equal to 3. It does help to get all of your terms on one side, so let's just do that real quick. And this is essentially 1 times x for our a, and then this will be 6 will be b, and then negative 3 will be c. And we can take all these numbers, plug them into this equation that we have up here, and we should be able to get a solution. So let's go ahead and plug this into our equation. We have x is equal to, and we have negative b, so we have our b is 6, so negative 6 plus or minus the square root, plus or minus the square root of b squared will be 6 squared. So 6 squared minus 4 times a, which is 1, and then our c is negative 3. All divided by 2 times, and then our a is just 1. And make sure to be careful with your signs sometimes when carrying it over. So for example, our c is actually negative 3, not just 3. So just make sure to check your signs when plugging it into the formula. All right, let's see if we can further reduce anything here. We can say negative 6 divided by 2 plus or minus, and then 6 squared is 36 minus 4 times 1 times negative 3. And be careful here, this is a negative 4, and then we also have a negative, so this is going to turn into a positive. So writing this out, we'll just say negative 3 plus or minus 36 plus 12, which will give us 48, divided by 2. And then reducing our 48, we'll have 24, and we'll have a 2. Let's see, 6, 4, 2, 2, and then 3 and 2. So we have a pair here, and we have a pair there. And then we have the 3 left over, which will stay underneath the square root. So finally, we will have x is equal to negative 3. And then we'll have 2 and 2. So that can come out, which will be a 4. 4, and then square root of 3 stays under, divided by 2. This will give us our final answer of negative 3 plus or minus 2 square root of 3, and we're done. Alright, now let's use the quadratic formula for a non-real complex solution. So 4x squared is equal to 3x minus 5. Let's go ahead and get everything over to one side so that it's easy to plug into our formula. So 4x squared minus 3x plus 5 is equal to 0. And now we have our a, our b, and our c that we can plug into our quadratic formula. So plugging it in, we'll have x is equal to negative b, or negative 3. So again, careful with your signs. This is a positive here, plus or minus, and then we'll have our b squared or negative 3 squared, minus 4 times a, which is 4, and then our c is 5, all divided by 2 times a, which is 4. Okay, so simplifying this, we will have 2 times 4, which is 8, so 3 divided by 8, plus or minus the square root of 9 minus 80 divided by 8. And if you notice, we're going to end up with an I underneath the square root, so let's just be mindful of that. We'll have 3/8 plus or minus the square root of negative 71 divided by 8. And we know that the square root of negative 1 is actually I, so we can simplify this by saying 3/8 plus or minus square root of 71i, all divided by 8, and that is going to be our solution. Okay, so let's look at solving a cubic equation. We have this thing called the sum of cubes formula and also the difference of cubes formula, where the sum of cubes formula is a to the third plus b to the third, and that's going to be equal to a plus b times a squared minus ab plus b squared. And then our difference of cubes formula is going to have a to the third minus b to the third, and that's going to be equal to a minus b times a squared plus ab plus b squared. So applying this sum of cubes formula, let's go ahead and look at this first example here. So first example, we have x to the third plus 125. Let's go ahead and plug it in. So essentially we're just dealing with an a here, and then this is going to be our b. So our b, what we know is that b is going to be the cubed root of 125, which is just going to be equal to 5. So let's plug this into our equation and see what we get. So we have x plus 5, and then we'll have x squared minus 5x plus 25, and this will give us x plus 5 is equal to 0, and then we'll have x squared minus 5x plus 25 is equal to 0. And now we can go ahead and solve for x in both of these equations to get our answer. So this one's pretty easy. X is just going to be equal to negative 5 for one of them. Now our second one, what we can do is use our quadratic formula to solve for this one. So our a is going to be 1, our b will be negative 5, and then our c will be 25. So plugging that into our equation, we will have x is equal to b, negative b, which will be 5 plus or minus the square root of b squared, which will be negative 5 squared, minus 4 times a, which is 1, times c, which is 25, all divided by 2 times a, which is 1. And simplifying this, we are left with 5 divided by 2 plus or minus the square root of 25 minus 100, all divided by 2. And we're going to have a negative underneath our square root, so we do need to simplify that one as well. X will be equal to 5 divided by 2 plus or minus these, let's see, plus or minus 5 square root of 3i, all divided by 2. And that's going to be our final solution. Okay. Sometimes you need to use the quadratic formula in order to solve for a specific variable in one of your equations. In our case, we want to try to solve for r, and our equation of v is equal to 1/3 pi r squared h. So let's see if we can go ahead and try to solve for r. So we want to try to isolate r here. Let's see what we can do first. We know that we have some constants here of 1/3 and also pi. Let's first multiply by 3 to get rid of that 1/3 on the right hand side. That leaves us with 3v is equal to pi r squared h. Pi is another constant that we can get rid of. And to do that, we need to divide by pi. So we're left with 3v divided by pi is equal to r squared h. And we're getting a lot closer to solving for r here. Let's get rid of h by dividing by h. And this will give us, let's see, we'll have 3v and then h pi is equal to r squared, and to get rid of the square we can take the square root, so square root. This will leave us with r is equal to plus or minus the square root of 3v, and then we'll have pi h pi, and this should be our final answer here. Okay. For example number 2, we want to try to solve for y. So let's go ahead and try to isolate our y onto one side. Even though we do have multiple y's here, we can still take care of those. So let's try to get everything onto one side first. 2my squared minus ny, and then we'll have minus 3p is equal to 0. And if you'll notice, this looks kind of like something that we could use the quadratic formula for. So this could represent our a, this negative n could be our b, and then this negative 3p could be our c. So plugging that into our quadratic equation, we will get negative b, which is negative n, so positive n plus or minus the square root of b squared minus 4ac. b in this case is negative n, so we'll have a negative n squared or positive n squared minus 4. What is a? A is 2m, so 2m, and then c is negative 3p. Then we'll take that and divide it by 2a, which is 2m, and our final equation will have y is equal to n plus or minus the square root of n squared plus, because we have a negative 4 times a negative 3p, plus 24mp, all divided by 4m. Okay. So now we have the discriminant. The discriminant essentially is a quantity under the radical in a quadratic equation. For example, b squared minus 4ac. In our case, that would be something like this. This would be the discriminant. And we can essentially look at that to determine the number of solutions and the type of solutions. So if your discriminant is positive and it's also a perfect square, you're going to have two solutions and it's going to be a rational solution. If it's positive and it's not a perfect square, you'll still have two solutions, but it will be irrational. And then our last two cases, if it's 0, you'll have one and it'll be a double solution and it'll be rational. And then if your discriminant is negative, you'll have two solutions and they'll be non-real complex solutions. So using the discriminant, let's look at some examples here. So we have 4x squared minus 12x plus 9. If we have the b squared minus 4ac, which is our discriminant. Plugging this in, what we'll have is negative 12 squared, because that's coming from our b, minus 4 times a, which is 4, and then c is 9. That gives us 144 minus 144, which is equal to 0. And if we said that it was 0, remember we'll have one double solution or one distinct rational solution. Example 2, b squared minus 4ac. So our b squared is just going to be 1 squared, minus 4 times a, which is 3, and then finally times positive 5 here. If we added that over to the other side, so this will give us 1 minus 60, or negative 59. And looking at negative 59, it's a negative number, so we're going to have two solutions, but they're going to be non-real complex. Last example here, 2x squared and then equal to 6x plus 7. If we go ahead and move everything over, we're left with, let's see, we'll have b squared minus 4ac. So negative 6 squared minus 4 times 2 times negative 7. That will give us 36 plus, because it's negative 7 times negative 4, 56, or 92. 92 is positive, and in this case, it is not a perfect square, so we have two solutions, but they're going to be irrational.